Good evening, folks. We just had a session on healthcare, how blockchain distributed ledger technology can help. But we need a reality check. We need to know exactly what are the shortcomings of this latest, greatest technology of blockchain. So for that, I would like to welcome Maria Vachino, who did research, who has been doing research in this field for the last 3 years. And she's going to share a lot more details about where or this technology needs work. She is currently a director at Easy Dynamics Corporation, where she's focused on IT modernization and identity access management. She's affiliated with cybersecurity for US government agencies. And without taking further ado, I would like to invite you on the stage.
Hello, everyone, and thank you. This is a last-minute presentation, and this is actually my second day at my new company. So prior to that, I was with Johns Hopkins University Applied Physics Lab working as a computer scientist for 13 years, and I primarily supported DHS Science and Technology Cybersecurity Directorate, and we started doing research into blockchain technologies in 2015. So I'm going to go through the lessons that we learned from all of that research over the course of 3.5 years or so. And this is from a computer science perspective. So it's going to be a little bit different probably from the sessions you just heard. So blockchains essentially are nothing new. The hype is new, but blockchains themselves as a computer science and data structure concept are not new. These papers are from the early 1990s, actually. What is new was the application to cryptocurrency and the hype. The hype is very new. And the hype seems to be strongly correlated to that first chart that you'll see with the funding. The VC community and the economic community, here we go, the business community has been extremely enthusiastic about blockchain. And so I think what we've been seeing is it has drawn a large number of people who have these previously fairly intractable problems or difficult problems that they really need to solve. And so blockchain has been presented as something of a magic wand. And the chart on the bottom there, that's a graphic that my team and I did to demonstrate just those are all unique stories over the past couple of years. The big peaks are recently in 2017 and 2018. And the green bars represent the positive pro-blockchain stories. Yellow is cautious and red is a warning. So it's been very unbalanced, the information about blockchain. So just get to, back to basics very quickly. What this is an example of what a blockchain is. This is just a data structure, and it's just hashing and linking data together in a manner so that if you take one of the pieces out, you can immediately know that the chain has been broken. And these chains are replicated massively in many cases. So it's called distributed, but it's actually just a replicated data store. And you've heard about the different types of blockchains, presumably, permissioned, private. So Bitcoin would be at the far end, and that's permissionless and public. A lot of the applications you're hearing about in the private sector now, excuse me, I'm getting over a bad cold, that you've heard about as blockchain 2.0, they're really, in some respects, blockchain 0.0, because they're actually reverting back to the basic computer science concepts. And they're taking out the ingredients that made Bitcoin possible. They're not using proof of work typically, they're using permissions. So it's actually using existing technologies, sometimes in a novel manner, sometimes not. And it's always important to contrast the abilities of blockchain technologies with just a plain database, because essentially it is a very limited specialized database structure. So in 2015, DHS S&T started an SBIR, which is a small business research call. And we started looking into, actually I can see the slides here, the applicability of blockchain to privacy-respecting identity management. And And we did a number of projects and pilots and research efforts over the past few years, and this culminated in a pilot with CBP's Office of Trade, looking at how blockchain could potentially facilitate trade. And so we have a lot of lessons learned from these efforts. And this is the biggest one. I don't know if any of you have seen this already. But for 99% of the use cases that I've heard, this is actually the reality. And a database is most likely the solution that you want, with other things, obviously. This was actually appeared in Wired, Bruce Schneier's article on blockchain, which I highly recommend that everyone read. So this is greater detail about what we learned. And this was originally published in an earlier version, at least, in the NIST blockchain document. It's NISTer 8202. So my team and I came up with this flowchart so that when people are interested or really motivated in doing some kind of blockchain pilot, or they're being sold blockchain solutions to their problems, to have an easy step-by-step flowchart that you can go through and just have a better idea about whether or not you should even be considering blockchain at all. Excuse me for 1 minute. So I'm going to go ahead and walk you through this quickly. Actually, let me see. Can you guys still hear me? Okay, perfect. So the first one, there we go. Do you need a distributed historical data store? If you don't need to maintain all of the history, then you absolutely do not need a blockchain, because what a database does for you is it gives you the current state, and if all that you need is the current state of truth, then you just need a database. So what blockchain does is it never allows you to delete or modify the entries. So you have the complete data store. So if you don't need that, oh, perfect.
They're recording it, so I want to make sure.
Okay. So if you don't need that, then you definitely do not need a blockchain solution. The next item is, will more than one organization contribute data? If all of your data is coming from a single source, then you do not need a blockchain. You can just have a single write, again, to a database or a centralized data store. Is it acceptable that entries cannot be changed or deleted? This is super important, because if you put a mistake on the blockchain or put something on there that becomes an issue later, you can't take it off. You can't modify it, you can't delete it. All that you can do is put another entry on there that says this is the truth now, but you can't actually easily get rid of any of the prior entries. And this can create all kinds of problems, especially when it comes to, if you have regulations and suddenly you're not supposed to put certain types of information in the public domain or share them, you can't go back. You would have to completely change your solution. And this is the one that I want to stress the most. I spent a lot of time, especially in 2016 and 2017, hearing about sharing data, sharing medical records, these types of things on a blockchain. This is super dangerous from a cybersecurity standpoint. So unless all of the data can be shared with all of the participants for all time, it shouldn't go on the blockchain itself. It's fine to put a hash of the information on a blockchain, but not the data. That includes encrypted data. So encryption has been misunderstood in the press, I think, about blockchain a lot. If you put encrypted data onto a blockchain and you share it, it's not safe at all. Because the minute that that private key is available, you can decrypt all the data. You cannot re-encrypt it if it's on a blockchain. So in a database, which is how encrypted data is normally stored, if the key is compromised or if it's stolen, then what you do is you re-encrypt it with a fresh key. You can't do that on a blockchain. So if your healthcare records, for example, are encrypted and placed onto a blockchain for sharing, then if your private key is stolen and that is placed on a blockchain somewhere, or if it's published or if it's made available to anyone, there's no way to take that data back. It is vulnerable for all time. So that's the most likely scenario. Excuse me. There are also other problems with encryption. Sometimes, although the math is solid, the implementations, the software implementations are not necessarily solid. So, encryption schemes can be broken, especially the software implementations. And the timeline for this is uncertain, but with the advent of quantum computers, which realistically it's going to be at least 20 years, I think. But eventually it's going to happen, and then all public key cryptography that we currently utilize is going to be broken. Symmetric key cryptography will be fine, but not public key, which is traditionally what's used for a lot of encryption. So for short-term storage of encrypted data, it's fine. Financial information that only is sensitive for a couple of hours or a couple of days, maybe that's okay, but nothing that's going to be sensitive for the long term. So if you make it this far, the next one is there contention over control of the data store? If there isn't, if the parties who need to share this historical information can agree on any third-party entity that can maintain a database, and this database can be replicated just like a blockchain can. It doesn't need all the consensus, but it can be replicated and exist in multiple areas, then you really don't need a blockchain. You can just use a managed database service. And then the last one is, do you want a tamper-proof log of all rights to the data store? And again, if you don't need that, then just a database is sufficient. So if you make it all the way through, then you may have one of the few use cases where a blockchain might actually contribute something that a traditional database with web services might not. So this is the biggest lesson that we learned. So who here has heard the story of stone soup? Not too many, okay. So stone soup is a fable. And there are these traveling soldiers, this is in the medieval times, going through a village, and they're hungry, and they have no food, they have no money, and there are no grocery stores. This is a long time ago. So they go around and they knock on the doors of everyone in the village, and they say, "We're hungry, do you have anything to spare?" And everyone says, "No, we have absolutely nothing." So they get the idea to stand up a kettle with some boiling water in the middle of the town square, and they put in stones, just rocks. And the people start to wander out, and they're curious, and they say, "What are you doing?" They're like, "We're making stone soup." And they sample it, and they're like, "But it just needs something. I'm not sure what it needs." And so one by one, the villagers go back to their pantries, and they bring back something that they had, an onion, a carrot, some salt, and everyone in the village starts to contribute to the pot of stone soup. Excuse me. So to me, this is a good analogy for blockchain. And this, I think, has been for us one of the greatest uses of blockchain, is that when you make the call to a community and you say, "I have a blockchain solution, give me your hardest problems," it brings people into the room together, and they can start to contribute their ideas. But even if you need the blockchain for the soup, you need a lot of other stuff. And this is not spoken about as frequently. This is the Identity Conference. Access control and identity for these private blockchains is a huge problem. PKI and distributed key management is something that the community has been struggling with for decades. This doesn't make it go away, it makes it worse, or it makes it more necessary. So you have distributed key management, you have all of the access control, the identity management, authentication, authorization policy. What you also need that traditional IT type solutions don't require as much of is you need all of these complex multi-party agreements, and you need governance, and you need to comply with laws and regulations, because what you're doing with all of these industries is all of these multiple parties who are from different organizations. If it's one organization, you definitely do not need a blockchain. But if it's multiple organizations that are competing, or governments, then they all need to get into the same room together multiple times with their lawyers, and they need to work out in detail their agreements. And they need to sign all the NDAs, they all need to agree on the same technology stack, and this is an extremely complicated and time-consuming process. What are you going to put on the blockchain? Everybody who is going to be contributing and participating needs to agree on the data schema. This alone can take a year, or months at the very least. And then you need to agree on how you're going to verify and validate the data. Because the issue with the blockchain is, unlike a database, if you make a mistake, it is preserved in this record, and it's going to be passed along as long as that blockchain is in existence. So you actually have to be more rigorous about your data verification and validation efforts before you put anything on a blockchain. Then, of course, you have the client applications. This is a peer-to-peer networking solution. So for organizations, this creates all kinds of interesting firewall issues. You need all these other components, web services, microservices, trust in the digital physical interface. You hear about trust a lot. All that you can trust is that the data that has been placed on the blockchain, or the hash of the data more appropriately, hasn't been altered. It doesn't provide any trust at all in the data itself. That has to be done prior to writing it to the blockchain. And you need to make sure that if you're putting information about a physical asset onto a blockchain, that you've done the due diligence to make sure that you can really trust the data that you're putting on there. And of course, you still need databases. So because most typically you're going to be just putting a hash of the data onto a blockchain, you also need a pointer that goes back to a database so that you can access the original data. And after you do all of this, then you can evaluate whether you actually need the blockchain or not, or if a database alone would have been sufficient. And then that would actually simplify all of this. So my advice, based on the years of research and the pilots that we did in DHS S&T, is if you really think that you want to experiment with blockchain technology, to always do an AOA, an analysis of alternatives, and compare it directly to a solution that does not have a blockchain. And really maybe do a design session and run 2 prototypes or pilots concurrently to see which one is better for your particular use case. So we were just focused on the non-financial use cases. I mean, Homeland Security, looking at how it can help with critical infrastructure issues. And the only things that I personally found that it may help with are certainly it could provide enhanced verification of historical records. You would be putting a hash of the record onto the blockchain, which would just be saying that this is the information, the data that I had on this particular date at this particular time, and I'm the one who put it on the blockchain. And there are a number of applications around that. Potentially protecting intellectual property, digital asset trading, and possibly trade. The issue that I saw with the trade efforts is that if you're, with all of the access control that you're putting on the chain to make sure that only the right people can read it, it makes it extremely difficult. And it also makes it extremely difficult to make sure that no business data is leaked. So for example, if you're in the trade space, you have competitors who would love to know when the competition is writing things to the blockchain, when they're shipping things, when they're receiving things, how much, who the information is being shared with. So the potential for business-sensitive data leakage is very, very high. And that's it. So thank you very much. And I think we have time for a few questions. Yes?
So you mentioned that for Bitcoin, some of the more traditional blockchain users, they're going more towards just standard encryption techniques rather than proof of work. Can you talk a little bit about why you think they're backing off proof of work as a validator?
So proof of work only. So for all of these use cases within the enterprise, it's inappropriate. It's very energy intensive, and it's only necessary if you are not permissioning people. So it's complete overkill. And it also requires massive scaling. So it only works. I can't remember the number of nodes required, but it's a very, very large number of nodes that you need to participate in the network for it to be even computationally viable. Yes?
In that last slide, you said non-financial applications. So during your research, you did find a place where blockchain could be viable for financial institutions?
We did not look at financial institutions. So, I mean, there are applications, obviously, with cryptocurrency. Whether it's a good idea or not is debatable. But we were looking at these blockchain 2.0 type applications for other sectors. Yes?
When you were going through your research, what was the problem that you guys were trying to solve? What was your research
So-
on blockchain? Was it?
So originally we were looking into whether it applied to the identity space at all and what the privacy implications were. And so that's where that one chart came from. Oh, I don't know how to, I think that's it. Where putting encrypted data, so people were saying that we can put identity data on a blockchain. I didn't see that really got us anywhere. It didn't solve any of the problems. And then we moved on from there because there was a lot of interest in the government. We moved outside of the identity space to trade and, you know, verification of data off of IoT devices, things like that. Yeah. Yes.
Did you ever explore or dwell into smart contracts at all? Was that in any way helpful?
So yes, I did look at smart contracts, and they're not contracts is part of the problem. The language in this space has been very misleading. So a smart contract is just a small computer program. It's software. And as we all know, software can be a little bit buggy. And if you put buggy code onto a blockchain, it can't be fixed, right? And then there's that problem of the digital physical interface. And so if anything changes with a real contract, a legal contract, then you get the lawyers involved, you can negotiate and you can fix things. You know, for example, if the routing number changes, it's not a big deal in the real world. But if you're relying on everything being perfect on a blockchain, I mean, that can create some real issues. So I wouldn't recommend smart contracts for most applications. Yes?
What are some of the positive things you've learned from the overall broad set of research you guys have done? I've heard a lot of caution. I'm just wondering, like, are there any clear successes or clear places where it makes sense for the private sector or government to continue the inquiry?
I think potentially continuing the inquiry for those very limited use cases where you need that historical data store and people really aren't agreeing, maybe for IP, so that rather than for things that don't necessarily need a patent and you just want to record your IP, this is something that could be done amongst different nodes, different organizations, even different countries. But the use cases are very limited. The most beneficial thing that I found was the ability of the enthusiasm around blockchain to get the right people in the right rooms to solve really difficult problems. Whether they need blockchain or not is something else entirely, but seeing the enthusiasm and the effort for solving these formerly fairly intractable problems has been encouraging for me. All right, well, thank you all very much, and I'll be available for questions afterwards.